Welcome to Chapter 4, Section 1, Using Graphs to Relate to Quantities. And our goal here is for you to know that graphs are used to show a relationship between two variables. Now, on the two variables, we usually have two types. We have an independent variable and a dependent variable. Independent variable is a variable that stands alone. It is not changed by other variables. Whereas a dependent variable is a variable that depends on other factors. Let me see if this makes sense. Your test grade may be a dependent variable because it's dependent on how much sleep you got the night before, how well you studied. All those factors could change your test score. Your test score is dependent on those variables. In column A, you see that we have our points. These are the points that are over here on this graph. In column B, you see that we have coordinates. You are to list the coordinate from column A with the coordinate from column B. So let's look at K. K is right here. Notice K is 2 to the right, up 1. So 2 to the right and up 1 is the point 2, 1. Go ahead and pause the video, then do the rest, and start the video again. Let's work through the rest. Point L is -3 up 4. So point L is -3 and up 4. Point M is to the right 3, +3, down 2. So right 3, down 2 is +3, -2. Point N is 0, 0. And if we're correct, then point P will be -2, -1, which it is. Really to work on for our vocabulary, we have analyze. Analyze is to examine carefully in detail to identify the nature and relationship of its parts. So it means basically to break down or dissect. So we have three words that come from the word analyze: analyze, analysis, and analyzed, which is past tense. Fill in the three blanks where you think they belong, restart the video, and check your answers. Do. Well, the chemist analyzed the data to draw a conclusion. This is past tense, so we're going to use the past tense version of the word. Jean needed to, that means she needs to do in the future, analyze. And again, both those are verbs. Now, a blank of the traffic at an intersection, an analysis. Analysis is the noun version of the word. In this problem, we want to know what are the variables of this graph. So the variables are what change. What can be changed in this graph? Yep, length and time are the variables. So the variables are length and time. So circle length and circle time. Now we need to show how the variables are related by underlining the correct word or words to complete each sentence. Go ahead, pause the video, attempt this, and start this up in a couple of seconds. See how you did. The length of the board, well, look at the board. The length is here. So it starts out this long, and then it gets a little bit shorter, and then shorter, and then shorter as time increases. So the length of the board decreases with time. Now, the length of the board is consistent, constant, or decreasing when you actually cut the board. If you look here, it stays this length, and then we cut it. Stays this length, and then we cut it. Stays this length, and then we cut it. So it's not really staying consistent. It's decreasing while we're actually cutting the board. During the time shown on the graph, there is 1 cut, 2 cut, 3 cuts. But as you notice, there is a bit of the board left here at the end of the time shown. Okay, go ahead, stop this video, try this problem, and turn the video on and we'll see how we did. Okay, once again, we're being asked what are the variables in the graph. Well, the variables in this graph are cost and the minutes of the calls. And then we're going to look at the relationship between the variables. So in this case, your cost is your dependent event because it's based upon the number of minutes. Your minutes, thus, is your independent event. In this case, the cost for the cell phone in June increases or decreases with the number of calls. Well, as the minutes increase, our graph increases. So the answer is increases. The cost of the cell phone in June is increasing for the first part of the month, constant or increasing. Well, this would be the first part of the month. And if you look, at that point, it's constant. There's no change, so it stays constant. So use your answers from exercise 11 to describe how the variables in the graph are related. So here I want you to restate what I said about the dependent variable of cost and how it's working on the independent variable of minutes of calls. Because the cost is what changes based on the minutes. Section, we're going to work on matching a table and a graph. So we have this table. And we see that we're going to use some sunscreen. 0 times, we have 5 ounces. We use it once, we have 4.8. So we used about 2 ounces. Second time, we now have 4.6. So we used another 0.2 ounces. Third time, we have 4.4. So we used another 0.2 ounces. So let's look at what happens. We're on 13. We're analyzing the data in the table. We're going to compete each statement with a correct choice from the list. We can use each word only once. So the amount of the sunscreen in the container blank after each uses. Does it slowly, does it fall, or does it decrease? Correct. It decreases. And the amount of sunscreen in the container changes, well, we already used decrease, so does it change slowly or does it change fall? Correct. It changes slowly. So the graph should fall at a slow rate. So which graph, A, B, or C, decreases slowly and falls? Well, this decreases, but I don't know if that's considered slowly. This is not at a constant rate. And remember, we talked about how the change between these were constant. They were 0.2 ounces. So we look at this one. Now, A says that at the bottom, at the end, we have 0 left. I don't think that's the case. After 1, 2, 3, 4 measurements, we still have some left. So that means our graph can't be A. And again, we said B was not consistent, so it can't be B. So we're left with C. And C is a slow decrease, falling. Let's take a look at problem 3. We are going to assume that we're on a swing, and we're going to move back and forth and swing higher into the air. Then slowly we will swing to a stop. Which sketch of a graph could represent how your height from the ground might change over time? Label each section. Okay, well, the first thing we need to talk about is what our two variables are. Our variables are going to be time, the time we're on the swing, and what? Will it be length of swing, distance from the top of swing, your height from the ground, or your height? Well, look back at the question. It says, what sketch of a graph could represent how your height from the ground might change over time? So, your height from the ground might change time. So our two variables are height from the ground and time. So looking at the graph, each one of these has height and time, height and time, height and time. And we need to consider the 3 cycles during the time on your swing. So this one, you stay a constant distance from the ground. So that's not going to be a swing because as you swing, it goes up and down. This one starts high, goes low, goes high, goes low, goes high, goes low and high. This one looks good except for the fact that you're not going to start high. When you start, you'll be lower and then you'll go higher, which is what this one shows. You start lower, you get on the swing, you get farther, as you increase in time, you get farther away from the ground, hit the middle of the swing, get farther away from the ground, hit the middle of the swing, and farther. Now, by middle, I meant your swing goes like this, and your middle is when you're closest to the ground. So that's what I meant by middle. So where we start low, swing high, and end low is the best representation of this. So we go ahead and make sure you understand what we've talked about in this unit. Our lesson check, we want to describe a real world relationship that could be represented by the graph sketched at the right. So looking at this graph, do we have a real world that could happen? So look at column A, and that's parts A, B, C, D, and E. And look at column B and decide which one matches which. And then go ahead and use a verbal description, and we'll talk about this in class tomorrow. And here's where we'll do the self-check. Make sure you understand variable quantities. That's your x and y's and the variable that changes. What it looks like when a graph increases, what it looks like when a graph decreases. Also make sure you know what it looks like when a graph is constant. And then go ahead and tell me how well you feel you get this. And I'll see you in class tomorrow.